Assalamualaikum warahmatullahi wabarakatuh. So for our video today, we will discuss about the chemical properties of alcohol. So we go to the first part, which is actually this video is consists of three parts. The first one is preparation of alcohol. The second one is second part is reaction of alcohol, and the last part is chemical test of alcohol. So we go to the first part, which is preparation of alcohol. So there are two reactions to prepare alcohol. The first one is the fermentation of sugar and hydration of alkene. So for the hydration of alkene, this one you have learned in topic 3, alkene. So it is the same reaction. So we go to the first reaction, which is fermentation of sugar. So in the fermentation of sugar, the sugar will be fermented by yeast to form ethanol. So during the fermentation, yeast cell converts sugars into ethanol and carbon dioxide. So what we see here, we have sugar, glucose, and then the yeast will break down the sugar to form ethanol. And then we have the second reaction is hydration of alkene. So in this reaction, alkene will react with water in the presence of acid catalyst, either H2SO4 or H3PO4, sulfuric acid or phosphoric acid, to form an alcohol. So in this reaction, as usual, H and OH will be added to the carbon-carbon double bond, and this reaction will follow Markovnikov rule. So what you see here, in this reaction, the H and OH will be added to the carbon-carbon double bond. So since that the carbon on the left side doesn't attach to any hydrogen, so OH will be attached there. So it will become this alcohol. And then we go to the reaction of alcohol. For the reaction of alcohol, we will learn four reactions. First is reaction with group 1 and group 2 metals, reaction of alcohol with group 1 and group 2 metals. And then second, oxidation of alcohol. Third, esterification. And then fourth, dehydration of alcohol. Actually, the dehydration of alcohol you have learned in the in chapter 3, I think, chapter 3, Alkene, the dehydration of alcohol. And then for oxidation of alcohol and esterification, we have do experiment on this reaction. Remember the experiment 3, we do the oxidation of alcohol using sodium dichromate and the esterification of ethanol with glacial acetic acid. Okay, that is the same reaction. Okay, we go to the first one, reaction of alcohol with group 1 and group 2 metal. So alcohol will react with metal from group 1 and group 2 to form ionic compound metal oxide and release hydrogen gas. So this reaction result in the cleavage of the OH bond of the alcohol to form metal oxide. So we look at the example of reaction 2-propanol with group 1 metal. So I use here is potassium. So in this reaction, O and H bond will be break. So the O will become O minus. Okay, and then it will attracted to K and forming K plus. So this is where the ionic bond is formed between O minus and K plus. Okay, this is where the ionic bond is formed and forming hydrogen gas. Where is the hydrogen come from? From the breakdown of O and H. So you will get the hydrogen gas. And then reaction with group 2 metal, for example, we have 2-propanol react with magnesium. Okay, well, we have 2 here. Okay, this is what we call as metal alkoxide. So this alkoxide is negative after the breakdown of O and H bond. So why we have 2 here? Because to balance the charge between the alkoxide ion and the magnesium ion. So magnesium 2 plus. So we need to have 2 alkoxide ion, and then forming and release hydrogen gas. Where is the hydrogen come from? From the alcohol. Okay, and then we go to the oxidation of alcohol. So oxidation product depends on the class of alcohol and the strength of oxidizing agent used. So actually we have two types of oxidizing agent. The first one is strong oxidizing agent and the second is weak oxidizing agent. So which oxidizing agent that is classified as strong oxidizing agent? We have four. First is potassium permanganate, potassium dichromate, sodium dichromate and chromic acid. All of these four oxidizing agent is classified as strong oxidizing agent. But for weak oxidizing agent, only pyridinium chlorochromate (PCC) only classified as weak oxidizing agent. So in the reaction of alcohol, so different type of alcohol will produce different type of products. So when we look here, we have primary alcohol. When react with strong oxidizing agent, it will form carboxylic acid. Okay, why? When primary alcohol react with PCC, which is weak oxidizing agent, it will produce only aldehyde. For the secondary alcohol, when react with strong oxidizing agent, it will produce ketone, while react with weak oxidizing agent, PCC, it will produce ketone. But the tertiary alcohol cannot be oxidized. So we look at this example. We have 1-propanol. 1-propanol is a primary alcohol. So we see here when primary alcohol react with strong oxidizing agent, it will produce carboxylic acid, COOH. Okay, this carbon, this alpha carbon will turn to COOH functional group. And then in the reaction of primary alcohol with PCC, which is weak oxidizing agent, it will only produce an aldehyde. Okay, this one is an aldehyde. Okay, for secondary alcohol, for example, here I have 2-propanol react with strong oxidizing agent, it will produce ketone, propanol. And then this one also so this secondary alcohol react with weak oxidizing agent, it also produce ketone. And then we go to the next one is the esterification. Alcohol react with carboxylic acid under reflux and is catalyzed by acid to form an ester and water. This reaction results in the cleavage of OH bond of the alcohol to form ester. So we see here our carboxylic acid react with alcohol. So the alcohol will break the OH bond, and while the ethanoic acid will break the CO bond, and then the C carbonyl here will bonded with this oxygen from the alcohol, produce ester, and then the OH and H, OH from carboxylic acid and H from methanol will produce water. Okay, that is the esterification. So, and alcohol also react with acid chloride to form an ester. So in this one, we have acid chloride. Okay, react with alcohol. So same as this one, same as carboxylic acid. In this reaction, your acid chloride will break the CCl bond, and the alcohol will break the OH bond. And then the carbonyl, okay, the carbonyl here will be bonded with this O to produce ester, and Cl will be bonded with H from alcohol to produce HCl. Okay. So we go to the last reaction, which is dehydration of alcohol. So alcohol undergo elimination reaction to form alkenes and water, and the reagent is concentrated sulfuric acid or concentrated phosphoric acid, and condition is in the presence of heat. So in this case, in this reaction, H and OH will be removed from the adjacent carbon, forming carbon-carbon double bond. So this one, this reaction you have learned in in topic 3, alkene. And then we go to the last part, chemical test of alcohol. So we have two tests. that we will discuss today, which is Lucas test and Iodophone test. So for Lucas test, this one you have do the experiment in experiment 3, the Lucas test. The Lucas test is a chemical test to differentiate class of alcohol. The reagent used is the mixture of concentrated hydrochloric acid and zinc chloride that act as catalyst is known as a Lucas reagent. So the mixture of concentrated HCl and zinc chloride is known as Lucas reagent. So when alcohol react with this Lucas reagent, it will produce a haloalkene or alkyl halide and water. So in this case, our hydroxyl group will be replaced by chloride from the hydrochloric acid, producing haloalkene. Okay, so the haloalkene form is insoluble in water, and then it will form layer or cloudy solution. So when you see here, this is the positive reaction of Lucas test. You see, we have layer here. Okay, which because of haloalkene is insoluble in water, so this is the cloudy part of the solution. The cloudy part here is the haloalkene. Okay, so how Lucas test is used to differentiate the class of alcohol. So we will look at the observation. For the primary alcohol, the solution does not turn cloudy, but for secondary alcohol, the solution will turn cloudy within 5 minutes. But for the tertiary alcohol, the solution will turn cloudy immediately. That is how we differentiate the class of alcohol using Lucas test by differentiate the observation. Okay, we look at the second test, which is iodophone test. So the iodophone test is often used to determine the methyl alcohol group. So what is methyl alcohol group? Is the methyl group that attach to the alpha carbon. Usually, ethanol and secondary alcohol will contain this methyl carbonyl group. Okay, so the reagent used is alkaline solution of excess iodine to form 3-iodomethane, and which is what we call as iodoform, and carboxylate ion. So in this case, our alcohol will be oxidized to form carboxylate ion. So the reagent used is alkaline solution of excess iodine in alkaline solution of excess iodine, that we can write as excess iodine in OH minus solution. So in this reaction, for example, we have two propanol. So this is the alpha carbon, and then we have two methyl group of the alpha carbon. So one methyl group will be extracted from the compound, okay, leaving only two carbon. So right now we have 3 carbon, and then when react with iodine, with iodoform reagent, excess iodine in OH minus solution, one of the carbon will be break down from the 2 propanol, okay, forming iodoform. So this is the iodoform form. Okay, and then leaving only 2 carbon, and then these 2 carbon will be oxidized to carboxylate ion. So the iodoform product is a solid that separate out as a pale yellow precipitate. Okay, when you see here the pale yellow precipitate, this is the iodoform CHI3. Okay, as a pale yellow precipitate. So I think that's all for our video today. So I hope that this video will help you to answer all of my questions. Okay, that's all for today. Assalamualaikum.